Greeting everyone. Before we start today's technical discussion, I want you to watch a short video about Linux, but don't just watch it casually. While watching, think about this question: how is Linux silently managing everything behind the scene? Okay, observe carefully how the system handles tasks, how it communicates with hardware, how it maintains stability. After the video, we will discuss some surprising facts you may not know. Okay, so watch it carefully. Okay, let me share my screen. So now that you have seen how Linux works, let me share something very interesting. Did you know most of the internet runs on Linux? Major clouds providers, data centers, supercomputers, they depend on Linux. Even Android phones uses the Linux kernel. So when you use your smartphone now, you are directly using Linux. Why do companies prefer Linux servers? Because they can run for months, sometimes years, without restarting. That's stability. That's a strong kernel design. That's efficient memory management. So let me ask you a very simple question. Have you ever seen a Windows system asking for restart frequently? Okay, we remain with this question. Guys, hackers find Linux harder to attack because strict permission system, it has user control, process isolation, open source auditing. Security experts worldwide review its code. That makes it strong. And here, everything is a file. This is one of the most powerful Linux ideas. In Linux, devices are treated like files: keyboard, file, hard disk, file, USB, file. This makes system design simple and powerful. Few operating system follows this elegant philosophy. And here the kernel is always active. The kernel never sleeps. It manages CPU scheduling, memory, IO, security. Even when you are doing nothing, Linux is still monitoring the system. When you learn Linux, you are not just learning commands, you are understanding how system thinks, resources are managed, security is enforced, and performance is optimized, right? And tell me a very simple question after watching the video and hearing these facts. Do you think Linux is just another operating system? I repeat my question. After watching the video and hearing these facts, do you think Linux is just another operating system? Yeah, the answer is no, right? It is the backbone of modern computing. Now you understand it's important. Let's go deeper into how Linux kernel, IU, and security actually work. So, first, let me ask you very something very different. When you press a key on your keyboard, how many things do you think happen? One? No, actually hundreds. When you press one key, there are lots of thing happens like the keyboard sends an electrical signal, the device driver translate it, the kernel process it, the system checks permissions, the application receives input, the screen displays output. All of these happens in milliseconds. And you think, I just type A. This is the power of Linux. Linux makes decision in microsecond. Which process is important? Who needs CPU time? Is memory available? Is this action secure? It's like a traffic controller at a busy airport. Okay, plans are here not needed. Like planes are landing, planes are taking off, signals are coming from everywhere, but no collisions because someone is managing the system. You don't see Linux on billboards. It runs most web servers, space research systems, scientific laboratories, banking infrastructure. It doesn't demand attention, it just works. And do you know why hackers respect Linux? Here's something interesting. Many cybersecurity experts use Linux, not because it's easy, but because it gives control. Linux assumes trust no one by default, permissions, isolation, authentication, security is built into its philosophy. So, here are some philosophy behind the Linux that Linux follows one simple principle: do one thing and do it well. Every component is small, efficient, focused. This modular thinking is why Linux scales from teeny embedded systems to massive supercomputers. Imagine you were asked to design an operating system. Would you allow every app to control hardware directly or create a central brain to manage everything? Actually, Linux chose discipline over chaos, and that's why it survived. Students, when you understand Linux deeply, you start thinking differently. You start asking how is memory allocated, how is CPU time shared, how is security enforced. You stop being just a coder. You start becoming a system thinker. See, technology is not magic, it is structured decision making. Linux proves that structure, discipline, and smart design can power the entire world. So now, let's not just admire Linux, let's dissect it, let's understand the Linux, let's explore IO, let's examine security because engineers don't just observe system, they understand them. Right? Okay, students, at the last, now tell me, explain Linux in a way you will never forget. Okay, imagine your computer is a boys' hostel, right? Okay, Linux is the hostel warden, very strict, right? Very disciplined, does not tolerate nonsense. Now imagine apps is the students, CPU are food, RAM is rooms, hard disk is your storeroom. Okay, now see what happens. You open Chrome, you open VS Code, you open music, you open 10 tabs. That means 10 students shouting, sir, I need CPU time. If there is no warden, total chaos. But Linux says, okay, you wait, you go first, you get second. Next, that is called scheduling. It gives everyone fair chance, no favoritism. RAM is like a hostel rooms, as I tell you. So limited rooms, too many students. Linux checks who really needs space, who is wasting space, who is sleeping and doing nothing. If a program is idle, Linux may reduce its priority. If RAM is full, Linux uses swap space. It's like saying room full, sleep in the extra hall, right? In Linux, not everyone is root. Root is like a principal plus warden plus owner, and normal users, just students. If a student tries to enter restricted area, Linux says permission denied. In Windows, sometimes, okay, fine, I trust you. But in Linux, prove it, right? Here, IO like visitors at the gate. So keyboard visitor, USB visitor, printer visitor. Every device must talk to the warden first. Driver is like security guard. Device says, I want to connect. Driver says, wait, let me check with kernel. Only then access is granted. And students thinks my system is running everything at once. No. CPU is like one chapati in mess. Everyone wants it. Linux quickly tear small pieces and gives each process one by one. So fast, you think everyone is eating together, right? So, why big companies love Linux? Because Linux doesn't panic. Windows sometimes restart required, but Linux say, I have been running for 200 days. Relax. Okay, let me ask you a question. If Linux was your class CR, what kind of CR would it be? Very disciplined, now. Very disciplined, no drama, no performance. So, students, Linux teaches us something. Be organized, be disciplined, control resources, don't panic under pressure. Because systems that stay calm survive. That's why Linux runs servers. And that's why engineers must think like Linux. Don't be a random application shouting for CPU time. Be the kernel, right? Be the kernel. Right now, you may feel like I'm just a BTech student, but remember this, every major system in the world was built by engineers, okay, who once sat in classroom like this. Like Linux itself was started by a student. Now, I told you in the earlier lecture, a student who was curious, a student who experimented, a student who kept learning. See, everyone can use technology, but engineers ask, how does it work? Why does it work? How can it be improved? When you study Linux deeply, you train your mind to think structurally. That mindset is more powerful than any programming language. See, your competition now is not your competition is not your classmates. Your competition is global. Cloud engineers, security experts, system architects. The question is here, are you preparing to just pass exams or to build systems? To build systems now. See, Linux teaches us discipline. Okay, even under heavy load, it stays stable. So learn from that. In pressure situations, don't crash. Manage your process, protect your energy, allocate your time wisely. If Linux can manage thousands of processes simultaneously, you can manage your goal. If Linux can isolate problems, you can separate distractions. If Linux can run for years without crashing, you can't stay consistent. So after today's class, ask yourself, Am I just learning for marks, or am I learning to become valuable? You are not here just to earn a degree, you are here to understand systems. And one day you may design the system the world depend upon. Okay, don't just run applications, run your life like a well managed kernel. Okay, so remain with this thought. Today's lecture is ended here. Keep running, keep focusing on your goal. Thank you.